Welcome to another video with Mr. M. In this video, we're going to be looking at some examples regarding momentum and impulse calculations. We're going to be using two main formulas, one for momentum, which we define as the product of mass and velocity, and the units for this quantity are kilograms meters per second, and impulse, which is basically the product of force and the time in which the force has been applied on an object, or in other words, it's also equal to the change in momentum. And units for this quantity is newtons per second or kilograms per meter times meters per second. So let's directly dive into the first example. As I go through the exercise, I will be highlighting some of the key variables, and hopefully you can also see my methodology on how to approach problems like this, where I'm underlining the key variables and then coming up with the solution plan. So we have a force of 400 newtons due east, acts on a 50 kilogram block for 4 seconds. The block was initially moving east at 10 meters per second. Question A, calculate the impulse exerted on the block. Question B, determine the change in momentum of the block. Question C, calculate the final momentum of the block. And question D, the final speed of the block. So let's see if we can visualize this in a nice way. So we have a block with a known mass, and this block was moving initially with the speed of 10 meters per second. So initially, this is what we see. We have this block and it is moving in this direction, so east, with a VI, meaning initial, with a VI of 10 meters per second. Now, what happens next? At time equal 4 seconds, what you have here is a force F being applied on the object, and this force is equal to 400 newtons, and this would have an effect, of course, on our block M, which now will be moving also eastwards, but with the final velocity that we don't know. Is that right? Yes, and that is right. So this is a velocity that we don't know. Now question A is asking for the impulse exerted on the block, and we say that the impulse is simply the product of F times delta T, and F in this case is going to be 400 times the 4 seconds, and this is going to be 1600 newtons times seconds, and that's our answer for A. B, the change in momentum of the block. B, the change in momentum, delta P. But as we said in the first slide, the change in momentum will be equal to the impulse, and therefore the change in momentum is going to be indeed 1600 kilograms times meters per second. So nothing new here. Question C, calculate the final momentum of the block. So question C, we want the PF of the block. Now the PF is going to be the mass of the block times the VF, which I remind you that we don't know. But what do we know? We know that the change in momentum delta P is equal to 1600, and that's what we calculated before. But the change in momentum is also given as m delta V, or simply put, the change in momentum we can write as PF minus PI, the P final minus the P initial. That's what the change of a quantity means. Change in time, it's the final time minus the initial time. So from this one, we can simply solve for PF, and PF is going to be the change in momentum plus the initial momentum. The change in momentum is 1600. The initial momentum is the mass of the object times the VI. So this one is going to be, the mass was 50 kilograms. 50 kilograms times the velocity was 10 meters per second. And this is going to be 1600 plus 500. Therefore, the PF, the final momentum, is going to be 2100 kilograms times meters per second, and that's for C. Now question D, the final speed of the block. The final speed of the block. So we're looking for the VF. We know now from question C that the PF is 2100. But we also know that the PF can be rewritten as M times VF. And if we solve this one for VF, we can have that VF is equal to 2100 divided by M. 2100, the mass is going to be again 50. So 2100 divided by 50 is going to give us a velocity, a final velocity of 42 meters per second. And that concludes exercise 1.